Anyway, guys, thank you so much for joining. I think we can get started with the class. Won't take much of your time. Both of you are very bright students. I know. I'm already aware of, and we'll take it with the basics. Okay, we'll try and understand decimal fractions, and maybe tomorrow morning 6 a.m. we'll meet again to finish off this chapter. Right? Okay. So we'll do a few of the practice questions, a few of the PYQs as well. And this chapter is common with your AFCAT syllabus as well. Okay, so we should not think in silos. Okay, whatever we are studying for CDS, if we study for CDS, that will essentially cover up your entire chapter for AFCAT as well, right? Okay, so it makes pretty much important for us to understand it in as elaborately as we can. Okay, so thank you so much, Jinagaraj and Abhikaran, for joining. I welcome both of you to the class and to the Faujis Academy and Willy. As you all aware that the Faujis Academy is the written wing for Willy. Okay, led by me and Guptesha sir over here. And today I wanted to talk a little bit about this decimal fraction as a chapter. And this is the fourth chapter that we are going to study. Okay, this is the fourth chapter we are going to study out of the close to 30 chapters that we would like to cover. Okay, and this is a very small chapter, so should not take more than 2 sessions to finish it off. And today and tomorrow we'll just finish it off. Okay, so fractions. Okay, what is fractions? Imagine this is a pizza, right? So in pizza, let's say there is like 8 slices. 2, 4, 6, and 8. So each of these parts, okay, each of these slices are basically your what? Each of these slices are basically your fractions. Okay, fractions. Okay, meaning what? It's a part of the whole. Part of the whole. Okay, whole means complete. Whole means complete, which means one. Okay, and when I say this is the part of the whole, let's say when I talk about one part, so this is one part out of how many parts? Out of 8 parts.
Yes.
Right? Out of 8 parts. Let's say you gave 2 of your pizza slices to your sister. Okay, you gave 2 of the slices. So how many parts you gave? You gave 2 parts out of 8 parts. Okay, so 2 by 8, basically this number is called nothing but your fractions, right? Simple fraction, this is one of the type of fraction. Okay, there are many different type of fraction. Okay, mixed fraction, simple fraction, and like fraction, unlike fraction, this and that, this and those. We have studied this more elaborately in AFCAT. Okay, but let's understand over here your textbook definition as far as Pathfinder book is concerned. They have given that simple fraction is that, okay, anywhere, let's say any fraction, which is not donated in terms of 10. Okay, if the denominator is not equal to, if the denominator is not equal to 10, that sort of fraction is called simple fraction as per your textbook definition in the Arihant Pathfinder book. Okay, but this is not completely true. Okay, simple fraction, another property is that the numerator has to be less than the denominator, or otherwise the denominator has to be greater than the numerator. Okay, this is also another property. And also they wanted to understand over here, I wanted to make you understand that they in the book they have described that if it is 1 by 10, let's say 5 by 10, 20 by 100 or something like that. Okay, if the denominator is 10 or some power of 10, this is called your what? Decimal fractions. Okay, so let's say 7 by 8, 1 by 20. Okay, 1 by 20, it's still that can be simplified in terms of 0.5 by 10. Okay, right? But still, I mean, these are the called Essentially 1 by 20 itself is not a decimal fraction. Okay, if it is like 1 by 10, if it is like, you know, 15 by 100, or let us say 237 divided by 1000 and things like that, these are called your decimal fraction as per your definitions in your textbook. But if you have to understand, in layman terms, I would not want you to understand simple fraction or decimal fraction in this way. Okay? I would just like you to understand simple fraction. If the denominator is greater than numerator, this is a simple fraction. Okay. And decimal fraction, all the fractions are called decimal fractions. Okay. Because all the fractions eventually can be expressed in the form of decimal. Okay, right, in the form of decimals, right? Okay, so these definitions are not important, but what you have given in the textbook, I just wanted to tell you, I just wanted to make you understand. So this is how things are. Okay, simple fraction, your numerator is less than denominator, that's it. Decimal fraction is all the fractions are decimal fractions, because eventually that particular fraction, or for that matter any fraction, can be eventually be expressed in the form of decimals, right? I hope I'm clear to both of you. We want to focus more in the application part of it rather than the theory part of it. Okay, we do not want to focus much on theory, but rather than on the application part of it, right? Okay, now let's understand what are the types of decimals or decimal fractions, right? The first one is your decimals. Okay, before I move forward, I wanted to understand, if I write 15 by, let's say, 17, is it a decimal? Is it a decimal? Yes or no? What do you think about this? The answer to this question is yes. This is also a decimal. Okay. Now you'll tell me, sir, no, it looks like a fraction. Yes, it's a fraction also, but when you simplify it, we'll get some number. Okay. We will get some number, 0 point what, how much? Something like that. Okay. So it can eventually be expressed in the form of decimals. That's why the term decimal and fraction, these two are interchangeable. Okay, decimal and fraction, and these two are pretty much interchangeable, right? So let's just not confuse it. Okay, we're just trying to understand that all the fractions can be expressed in the form of decimals, and all the decimals can eventually be expressed in the form of fractions. So we wanted to cover the types of decimals. Okay, the first one is the recurring decimal. So what do we mean by recurring? Recurring means repeating. Okay, recurring means repeating, right? Okay, let us say, for example, I say 0.33333333. Okay, which can also be written in the form of 0.3 bar, right? Or in other terms, you can also write it in the terms of 1 by 3 as well, right? Right now. So, or 3 by 9, which eventually gives you a 1 by 3, right? How we moved from 0.3 bar to 1 by 3, we'll see that as well. Okay. So, recurring means it's repeating. Let us say 0.1427, 1427, 1427, 1427. Okay. What we see over here? 1427 is repeating. Okay. Wherever the decimals are repeating, let us say 20.68686868686868. Okay. So all these 686868 are your repeating, or in other words, what? Recurring. Okay. Or let's say, for example, 7.24. Okay. 1 2 1 2 1 2 1 2 1 2 1 2 dot. Okay. Now you will ask me, sir, 24 is not repeating. Okay, but other than 24, this number is repeating. No, it can be written in the form of 0.241212 bar, right? Okay, so this is what we mean by recurring decimals, right? Now we have pure recurring decimals. So pure recurring decimals means what? That after this decimal, after this point, okay, after this point, the number is repeating. The number is repeating. Okay, these are your pure recurring decimals. 0.1478, 1478, 1478, 1478, 1478. Okay, 1478, like this. These are your pure recurring decimals. Okay, let us say 20.585858585858. By the way, 5858 was my school roll number. Okay, right? So 20.58 bar. Okay, after decimal all the numbers are essentially repeating. Okay, and what is mixed recurring decimal? What is mixed recurring decimal? Let us say 0.125 and then 123, 123, 123, 123, 123 and dot dot dot. Okay, basically 0.125, 123, 123 bar. That's it. Okay, this number, this after point, this is not repeating. Okay, but over here in pure recurring decimals, all the numbers or the set of numbers, okay, are repeating after point. Okay, but over here in mixed recurring decimal, after point, there are three numbers 1 to 5 over here which is not recurring or repeating. Okay, and the meaning of recurring is same as repeating, right? Is it clear, guys?
Yes.
Is it clear? Just enjoy the show today. Okay, so if I have to ask you, let me give you a number 0 point. Okay, and okay, so tell me which one, this one is what? Is it a pure recurring decimal or a mixed recurring decimal?
Pure recurring decimal. Pure, sir.
Yes, pure, absolutely. Okay, and this one is your mixed recurring decimal,
Mixed.
right? So I hope you understood all these preliminary concepts. We'll move to other stuff. Okay. I specifically wanted to talk about this decimal fraction over here. Why? Because many of the chaps, they have this problem in understanding doing this, addition, subtraction, multiplication, and division. Okay. Let us say if I ask you 0.3 plus 0.3 to, okay, let's say 0.33 only plus 0.333. In FCAT examination, this question was asked. This type of question was asked. Okay, so how will you do the addition? Okay, so the method of doing the addition is that 0.3. Okay, then this is done, then 0.3 and then 3, 0. Now the third term. Okay, 0.333, 0.3333. Okay, what did we observe? All the points has to be written in the proper alignment. You cannot write, okay, 0.3, okay, or 0.33 or something like that. Okay, or something like 0.33 like that. Okay, or something like 0.33, or adding this like this. It gets, you should not do that. Okay, this is the way it should be done. Okay, it also essentially means that you can put zeros also. Put zeros. Okay, now addition 3, 6, 9, 12. So this is how the addition operator works out with decimal. Same is the case for multiplication as well. Let us say 0.4 minus 0.762. Okay, so how will you do that? 1.4, point has to be written in proper alignment, 0.762. Okay, write down 0, 0 over here, minus, okay, 8, 3, 6, right? So this is the answer. Okay, Now let's talk about little bit about the multiplication. Let's say 0.2 into 0.2, okay, 0.002 into 0.00002, okay, into 0.00002, okay, one more zero, 5 times 0, okay. Tell me what is the answer, okay. Or let me make it a little bit easy for you. Yes. Tell me quick, guys, okay. The method to do that is first forget the decimal. Just forget the decimal. What are the numbers? 1, 2, 3, 4, 5. Okay. 5 times. 4, 8, 16, 32. Write down 32. Okay. Now, after point, how many numbers are there? 1, 2, 3, 4, 5, 6. Okay. 6. 1, 2, 3, 4. Okay. Plus 4. 1, 2, 3. Plus 3. Plus 1, 2, 3. Okay, plus 3. 6, 4, 10. Plus 3, 16. So the point has to be placed after 16 digits. Okay, from the right hand side count 16 digits. But we have only 2. Okay, so let's just put in what? Let's just put in some zeros. Okay, we need to have the point after 16 digits from the right hand side. From this hand side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now you give the point and 0, right? This is what will mean the multiplication of this will look like this. Is it clear to you all?
Yes, sir.
Janagraj, is it clear to you?
Yes, sir. Yes, sir.
Cool. Thank you so much. Yeah. Now, how do we work out with the multiplication? Let's say 0.00066 divided by 0.22. Okay. How do you do that? Okay. In the denominator, 0.22. Okay. So if this point goes away, then you have to write in the multiplication 1, 2. 2 digits are there. So 1, 0, 2 zeros. Okay. In the denominator, this point goes away. 1. How many? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. These 2 zeros and these 2 zeros got cancelled. This 2266 3 times got cancelled. Okay. 3 divided by 1. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So write down 3 after how many zeros? 1, 2, 3, 4. Okay. So after 4 digits. So 3, 1, 2, 3, 4. Dot 0. This is how it will look like in the division. Right?
Yes, sir.
Yeah. Okay. So if you did not get it, let me tell you once more. Okay. Let's say 0.000. Let us say some number, let's say 88 into, let's say 0.55, okay, divided by 0.0011 into 0.011. Okay, how will you do that? This point goes on to a toss. 1, 2, 5, 5. 2 numbers are there, that means 2 zeros. Okay, this point goes on to a toss. Then write 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 into this point goes on to a toss. 1, 1, 2, 3, 1, 2, 3. Again, this point goes on to a toss. 1, 2, 3, 4. Okay. This 4, 1, 2, 3, 4. Okay. This 3, 1, 2, 3, 1, 2, 3. Zeros cancelled. Okay. This one will go 8 times. This one will go 5 times. So these two multiplication will become how much? 40. Clear, guys? Thank you so much. Shall we move, and then we'll move to the next question. Okay. So the next point is about to convert pure recurring decimals into fractions. We understood what do you mean by pure recurring decimals. Okay. You guys take one moment of your time. Okay. And let me know what is the answer. I'm just going to fetch a glass of water for myself. So Just give me one moment, okay? You can write in the chat. Yes, tell me, what's the answer? Okay, C, Avikan is saying C. Okay, fine. Let me evaluate it. Okay. See how exactly it works out. Okay. How exactly it works out. We need to turn this number. One moment. We need to turn this number 1.27 bar into P by Q form. Okay. That means we need to turn this decimal into fraction. Okay. So we start by assuming this value as x. Okay. Now tell me, what will be the value of 10x? Will it be 12.7272727272? Likewise, will it go to the left hand side of the decimal? Now tell me, what will be the value of 100x? It will be equal to 127.272727. Basically nothing but your 127.27 bar. Right. Now this is your equation 1. And this one, let's just assume this one as your equation. Okay. Now if we do equation 2 minus equation 1, what will we get? In the left hand side, essentially we will be doing 100x minus x, and in the right hand side we will be doing 127.27 bar minus 1.27 bar. Okay, and this bar will get cancelled. That means 99x is equal to 126. Right, guys? That means x is equal to 126 divided by 99. Is it divisible by 9? 14 times and 9 times. That means 14 by 9 is your answer. Yes, Abhikaran, your answer is correct. Okay, 14 by 9 is your answer. Did you guys understand how did we come to 14 by 11, not 9? Okay. Did you guys understand the mechanism behind it?
Yes, sir.
Okay, cool. So is there any short way to do this, to find this one? How to write in terms of fractions? Okay. There is a short way. First, forget the bar and point and write down the number. Okay. First, forget the bar and point and write down the number. Minus, write down the number which is on the left hand side of the point. 1. Divided by, write down 9, the number of times, there's two number over there, 2 and 7, over which bar are there. That means you will write 2 times 9. That's it. 126 by 9. If I have to ask you 1.58 by bar, so how will you write? 158 minus 1 divided by 58. Two numbers are there, that means bar 99. That is your 157 by 99. Got it? Now if I ask you, let us say 0.2736 bar, how will you write?
2736 by
2736 minus
by
0.
0 minus 0.
Yeah, minus 0 means there's no point of writing that.
Yes.
Yeah. Divided by 4 times 9. That's it. Janagraj, got it?
Yes, sir.
Let's move on to the next. Yes. Take one moment of your time. The vulgar fraction. Vulgar fraction is nothing but your simple fraction. Okay. Okay. Vulgar fraction means your simple fraction. Okay. It's not a Greek. Vulgar fraction, it's not Greek. So x is equal to 1236 bar. Okay, what will happen if we do 100x? Will it become 12.36 bar? And what will happen if we do 1000x? Will it become 1 2? Now two numbers, when it was x, okay, we just wrote it like this, okay, 0.1236. When we did 100x, two of these numbers 1 and 2 went to the left hand side of the point. And when we do 4 times 0, that means 10,000x, that means 4 numbers will come to the left hand side, right? Now let's put in the whole idea is that we want to get rid of this bar. Okay, the whole idea is that we want to get rid of this bar. Okay, so that is why we are representing in such a way so that it's easy for us to get rid of the bar. Okay, so now we do 2 minus 1. 2 minus 1. How much is that? 10, 1, 2, 3 x minus 10x, which is equal to 1, 2, 3, 6.36 bar minus 12.36 bar. Tell me, how much is that? Okay, it's 9990. X is equal to how much? 1224, right? Am I right? So the x value of x is equal to 1224 divided by 9990. Please simplify it. Tell me which one is the answer. It's divisible by 9. Okay. Divisible by 9 means 1110. 1 time, 3, 2, 6 time, right? Is it correct, guys? Or have I done some mistake somewhere? 1224 divided by 9 is your 136, right? And if we do this 136, how much is that? It's your 68. It's divided by 5, and then again 5, and then again 5, right? So this is your 68 divided by 555, right? So the answer option over here is
D.
D, none of the above. So shall we or do we have any better way of doing this? Do we have any better way of doing this? Yes, we do have a better way of doing this. X is equal to 0.1236 bar. Okay. First step is to write down the number, forgetting the bar and the point. Okay. Minus, forget the point and forget the number under the bar. Okay. So that means only 12 remaining, only these two numbers remaining. That's it. Okay. Now, how many numbers have got bar under it? Two numbers, right? Two numbers. That means 3 and 6. Write down 9, 9. Okay. How many numbers after point have not got bar over it? 2, right? 1 and 2. Their number is 2, 1 and 2. Two numbers. 0, 0. That's it. Is your answer. Got it? Got it, guys? This one is
Yes,
little
sir.
dicey for us to understand. So I will give you one more scenario wherein let's say x is equal to, let's say 5827 bar. How will you write it? 0.5827 bar. First, forget the decimal and bar, write down the number 5827 minus. Then forget the number under the bar and forget the point. So what number is remaining? 58. Okay. How many numbers under the bar? How many numbers are there under the bar? Two numbers are there. That means 2 and 7. 27. That means you write 2 times 9. How many numbers after point haven't got bar under it? Two numbers, 5 and 8. That means 0, 0. That's it. Okay. So if I have to ask you 1.36942 bar. Okay. Get me the answer to this.
369,425.
It's 1.36. So first forget the bar. Okay. First, forget the bar and write down the number. Bar and decimal.
Sir,
1369.25.
some the answer is option B.
This one, 8.
Yes, sir.
Okay.
Calculation errors.
Okay. One moment. So this one, let's just complete this one. Okay. So this one, what did I tell you? That write down first, forgetting the decimal. We'll come to that. Okay, Vikram, one moment. Okay. We'll first forget the bar and the point and just write down the number. Then forget the number under the bar and also forget the point and write down the number. 1369 divided by how many numbers have got bar over it? 3 numbers. Write down 3. Okay. How many numbers after point haven't got bar over it? 3 numbers. So 0, 0, 0. That's it. Okay. This is your answer. You do it in the simplified form. Okay. Let's try to do this example once more. 0.1236 bar. Okay. Which means what? 1236 minus 12 divided by 9900. That means 1236. Sorry. One moment. 12 divided by 9900. Right. Right. Simplify it, guys. I just trying to simplify it. Okay. If we simplify it, it's like 12449 3 2 9 1100. Yeah. Let me know if I'm doing any calculation error or something like that. Okay. So option B. Have I done any calculation error, guys? How is it option B? Yes, option B is also correct. 1224 divided by 9900. It's your I'm using calculator. Okay. It's your 0.1236 363636 bar, and 102 divided by 825 is also 0.1236 bar. Okay. Right. But then how are we not reaching this number? Whether 102, yes, this 102 divided by 825 can be further simplified. Okay. That means 3 and 4. Divide by 3. Right. And now 6, 8. Divide by 5, 5, 0. Okay. 34 divided by 275. Are these same, guys? Are these same? That they have given 1 or 2 divided by 8 to 5 is not in the simplified form. Okay. Got it, guys? Yes or no?
Yes, sir. Yes, sir. Got it.
Cool. Thank you so much. Let's move on to the next one. Yes. Comparing the fractions. Okay. Comparing the fraction, I wanted to talk a little bit about, let's say you have 2 by 3 and 4 by 5. Tell me which one of these two is greater? 2 by 3 is 0.66. 4 by 5 is 0.8. Right?
4 by
Which one is
6.
greater? 4 by 5 is greater. Right. 7 by 9, 11 by 13. Which one is greater? Now it's little difficult to, change it into decimals, right? Yes or no? So there is another formula over it. There is not formula per se. Multiply this denominator with the numerator. 91. Okay. Then multiply this left hand denominator with this numerator. Which one is greater? 99 is greater. That means this fraction is greater. Will you remember this? Will you remember this?
Yes, sir.
Remember this, okay? Very handy. 7 by 10 and let us say 13 by 16. Tell me which one is greater. Do it like this. 130. Which one is greater? 13 by 16 is greater, right? Okay. This is how the comparison has to be done. Okay. When two fractions are there, right? And when there is no, there's another way also. 7 by 9 into 11 by 13. First take the LCM. Okay. When you take the LCM, what happens basically? Okay. We multiply it by 9 and 13. And we also multiply this one by 9 and 13. Okay. This one gone, this one gone, this one gone, this one gone. 91, 99. Okay. Essentially, it means the same. Does it mean the same, guys? The thing that I have taught you over here, that crisscross thing, does it mean the same? It essentially means the same, yes or no? Okay.
Yes.
You're still reaching this 91 and 99. This one is greater, that's it. This fraction is greater. Okay. Now let's try and understand, try to solve this question. Find out the LCM of the denominator. What is that? Can we work out any further? Can we work out any further? No. So 150 into 7, 1050. Okay. 2 by 3 into 1050. 5 by 6 into 1050. 16 by 25 into 1050. 3 by 7 into 1050. Okay. Look, we do not even need to find out 1050, then divide by 3 and find out. Okay. Just look at these numbers. It has to be divided by 3, no? Just leave this 3 behind and 50 into 7, 350. 350 into 2, 700. That's it. Okay. It has to be divided by 6, no? Leave behind 3 and 6. Okay. So 25 into 7 is how much? 175. 175 into 5 is how much? 875. It has to be divided by 25. So leave behind 25 and then do 3 into 6. 3 into 2, 6. 42. So 16 into 42. Leave behind 7 in this one. Okay. How much is that? 25 into 2, 50 into 3 is 150. Into 3 is how much? 450. How much is this value? This much? Now tell me which fraction is the lowest. Now tell me which fraction is the lowest, guys.
3 by 7.
Yes, 3 by 7. Okay. Now which one? 672. That means 16 by 25. Then 700 means 2 by 3. Then you're 5 by 6. Right? Clear, guys? Is it clear? How do you compare?
Yes,
Is
sir.
it clear? Shall we move? Abhikaran, shall we move?
Yes, sir.
Cool. Thank you so much. Let's move on to the next question. Yep. How do you find the HCF and LCM of decimal fractions? How do you find that? Let's finish it off. Let's call it a day.
Sir, can make the denominator.
The first step is to write down, let us say 1.6. Okay. 1.6. Express this in the form of, in a uniform numbers with uniform number of, digits after the point. Can 8 be written as 8.0? Yes or no? It's same only, no? 2.4 is already in this format. 2.4. Now, forget the decimals. FD. Not fixed deposit. 16, 80, 24. Now tell me what is the LCM? Tell me what is the LCM, guys? The LCM, guys. Is it 240?
Yes, sir.
Is it 240? Okay. It's 240 is the LCM, but remember we have forgotten the decimal. And decimal is at what? One place from the right hand side. So just from the one place from the right hand side, put a decimal. So what is your LCM? 24. Now tell me, what is the HCF?
0.
Is it 8? Is it 8? I mean,
Yes, sir.
HCF of these numbers is
Yes, sir.
8. But remember, we forgot the decimal over here. Now we need to recall back. Recall back that decimal, and it has to be from the 1 point from the right hand side. 1 point from the right hand side. That's it. 0. 0.8. So 0.8 is what your HCF, and 24 is what your LCM. Okay. I give you another example. 2.4, 3.66, 4.528. Okay. How will you find the HCF and LCM? First, 2.400. Why 00? Because 5 to 8. 3 digits are there after point. 3.660. 4.528. Now forget the decimals. Now find the LCM and HCF. Okay. Let us say some number. Okay. X, Y, Z, P, Q, R. Okay. This number. LCM has to be, from the right hand side. After how many digits? We've forgotten the decimal after 3 digits. So 1, 2, 3. So X, Y, Z point PQR will be your LCM. And let us say you found out HCF is equal to ABC. Okay. But after 3 point, it has to be, so 0 point ABC will be your HCF. Is it clear to both of you?
Yes, sir.
Yes, Janagraj, is it clear to you? Janagraj, is there everybody? Okay, he's not there. Okay. No problem. So with this, we'll close the class for today, Abhikaran. Thank you so much for joining, and we'll meet again soon. Okay. Let me just sleep over it if I want to take a class tomorrow morning or not at 6 a.m.